Welcome. This is a universally compliant, more environmentally friendly and rigless tubing compaction project presentation, made possible by the Oil and Gas Technology Center, Oil and Gas Innovation Center, the University of Glasgow, and Oilfield Innovations. In this part of the presentation, we'll explain how tubing compaction works in detail. This is the necessary equipment for low-cost slickline and electric line, whereby a mast is used to lift the various small tools like lubricators and various other aspects, while a winch uses a wire to hoist small tools operated within the tubing so that the tubing can be cut, and also the remaining tubing can be used to pump cement plugs. In many cases, the primary P&A plug is set by bullheading cement into the reservoir to isolate it. Tubing compaction would then be used to compact tubing above the isolated reservoir and set a secondary P&A plug. Further cutting and compaction of tubing would then allow an environmental plug to be set. Tubing compaction works because engineers purposely design wells to contain 80 to 90% liquid space, so as to maximize production. And using the liquid space of a well, tubing can be compacted into a smaller space to allow room for casing access that can be used to log the cement bond behind the casing and place a cement plug, with the compaction packer blocking any gas migration and supporting the cement plug. Tubing compaction first involves isolating the reservoir, which can be similar to the conventional method of bullheading cement as shown here. In this particular example, the second phase would involve cutting and crushing pipe so to create a casing space through which through-tubing logging could monitor or measure the bond of the cement behind the casing, and subsequently place the secondary barrier, shown on the right in red. Further compactions would involve allowing the setting of an environmental plug above a piston used to compact the tubing. Knowing the overall process, let's talk about the details of tubing compaction. Firstly, tubing compaction requires vertically splitting tubing to weaken it so that it can be compacted. The second step of a tubing compaction process is using proven technology to sever the tubing string and also to circulate cleaning fluids, proven cleaning fluids, into the well. This is followed by the third step of severing the tubing again using commercial tools, and then placing a through tubing inflatable packer to be used as a piston for compaction. Step 4 of tubing compaction involves using a pump to drive a piston, which is an inflatable packer inflated to the pressure that allows both motion and sealing of the piston to the casing, which can also be used to clean the casing and ultimately, when later placing the plug, prevent gas migration, so that when the piston is driven down, it pushes the tubing, the cut tubing, into the 80 or 90% liquid space of all wells. Steps 1 through 4 are critical because they create casing access that allows through tubing commercial production casing cement bond logging tools to assess the plug and abandonment barrier behind the casing in step 5 of the process. Casing access is the primary reason why hydraulic workover units and drilling rigs are used to pull the entire completion. If you can log the casing cement through the existing in situ tubing without pulling it, you don't need a drilling rig or a hydraulic workover unit. Accordingly, a rig equivalent cement plug can be placed without a drilling rig because you have casing access above a plug or an inflatable packer, which prevents gas migration upwards and supports the cement from migrating downwards. Or alternatively, if the step 5 cement bond logging shows that no cement is behind the casing, a plug can be set within the casing to allow easy access and removal of the Christmas tree at the top of the wellhead so the rig can get in more cost effectively to perform casing milling and cementing operations. As casing milling is only required 20% of the time, this method allows savings or the use of rigless operations to replace rig operations in 80% of the cases. Now that you know how tubing compaction works and why it's important, the next video in this series of videos shows you the OGTC and OGIC validation projects associated with proving that tubing compaction works. Thank you for watching this Oilfield Innovations video.